So what is aspect extraction? Aspect-based sentiment analysis is a task involving the identification of key terms that refer to important features of a targeted product or service, along with associated positive and negative emotions. It is frequently used in opinion mining. Let's take this sentence as an example. There is only one aspect, pasta. From reading this, it's clear that the corresponding opinion is chewy. Now, normally it's not this simple. Typically, there are several aspects and sentiments in the same sentence. There are two main subtasks involved in aspect extraction. First, extracting aspects from text, for example, pasta from the previous sentence, and second, categorizing extracted aspects into one broader aspect. For example, pasta and beef would be categorized into one aspect, food. To complete these tasks, past studies have utilized two main approaches, supervised and unsupervised. In the supervised approach, a labeled dataset is required. In a real-world scenario, a dataset will not be so nicely labeled. This is our motivation for choosing to use the unsupervised approach. With this approach, a set of grammatical rules are defined to identify aspects through their role and position within the sentence. Our motivation for this project involves both societal and technological benefits. By summarizing a product or review, a potential buyer or business owner can instantly get a better understanding of what they're trying to buy or sell. This will lead to overall improvements in these services and products. Additionally, with social media becoming as important as it is today, it will be an important tool to isolate cyberbullying and negativity. Previous rule-based methods have not been as accurate as supervised methods. We believe that combining a rule-based method with additional unsupervised techniques will increase accuracy, hence contributing to the problem of unsupervised aspect extraction. Now let's dive into our approach. Let's use this example of a restaurant review. We call each word in this review a token. Our approach is split into three stages. First, we extract noun chunks, which are then converted into candidate aspects. The candidate list is then purged of incorrect aspects. Noun chunks are simply base noun phrases, a noun plus the words describing them. These are first extracted from the sentence through a set of grammatical rules. These grammatical rules make use of a token's dependency and part-of-speech tags. A token's dependency tag represents its grammatical structure and the relationship it shares with its parent token. For example, good is an adjectival modifier of spreads in this sentence. A token's part-of-speech is a category of the word based on its definition and context, and relationship to neighboring words. The noun chunk extraction function looks for specific dependency and part-of-speech tags. If the token's part-of-speech tag is none of these important ones, it is skipped, as it can't be part of a noun chunk. If it does, the next rule is checked. If the dependency tag of the token is any of these important dependency tags, it is selected along with its children as a noun chunk. The parent token is also checked to see if it belongs in the noun chunk through using the same rules. Coming back to our sentence, the important tags are already highlighted. From this, we extract noun chunks. We then carefully inspect and prune these noun chunks to form candidate aspects. First is a technique called coreference resolution, or CoRef. CoRef is used to recognize aspects that co-refer to an already existing aspect. If this is the case, only one should be passed through as an aspect. The motivation for using this is that it will heavily remove clutter in the results. Using this sentence as an example, we see that pasta and it both refer to the same aspect, pasta, but they are both originally extracted as noun chunks. It should clearly not be a final aspect, as it is just a co-reference of pasta. By using our CoRef method, we isolate this issue and remove it from the noun chunk list, while passing pasta through as a candidate aspect. To do so, we set up a backlist of pronouns such as it, they, he, her, etc., and perform checks every time these pronouns are encountered. As a contingency plan, we evaluate the performance of our model with and without CoRef to diagnose problems and effects. Next, we remove all sentiment words from the noun chunks, as they are not actually a part of the aspect itself. To do this, a sentiment lexicon, a dictionary of sentiment words, is accessed to identify these words. The opinion word will naturally be attached to the aspect in a noun chunk, as it is a child token of the noun token. Taking great beverage selection as an example, great is removed from the noun chunk as it is describing the aspect, which is beverage selection. Applying this on our example, we get a list of candidate aspects. The last stage of our approach involves removing all irrelevant or incorrect aspects from our list using an unsupervised filtering technique. We iterate over each of the candidate aspects, calculating a similarity score to each other candidate. If it does not meet similarity requirements, it is removed from the candidate list. So how do we calculate this similarity score? First, the candidate is converted into its word embedding form. This is a 300-dimension vector representing the token itself, and similar tokens will have similar vectors. Once the tokens have been transformed into their word embedding form, a similarity score between the two candidates is then calculated through finding the cosine of the angle between the two vectors. This is completed for each candidate with every other candidate. Now, what determines if an aspect is actually purged? We define two similarity thresholds: an average similarity, the average similarity of the candidate to every other candidate, and a maximum similarity, the highest similarity shared with another candidate. We expect that if a candidate is a true aspect, it should be very similar to at least one other candidate. A threshold for each was determined through observing the optimum number and coherence of the resulting aspects. A candidate is purged if its average similarity is less than 20%, or if its maximum similarity is less than 60%. We first evaluate our model on two labeled datasets. The first is a dataset of restaurant reviews, with which we compare a model against previous unsupervised methods. Second, a dataset of discussions on urban neighborhoods is used to categorize aspects and evaluate based on how accurate the categories are formed. With the semi-val dataset, we extract aspects and compare them against the true labeled aspects, calculating precision, recall, and F1 score. Comparing against previous unsupervised methods on the same dataset, we found that our approach before applying CoRef had the highest recall, meaning the initial list of aspects matches the true aspects most accurately. After implementing CoRef, the recall decreases, while the precision and F1 score rises to the top. This shows that the CoRef approach correctly removes pronoun clutter. At the same time, it seems to have removed some correct aspects. We found that if an aspect references a pronoun after the pronoun in the sentence, it is taken as the co-referring aspect and removed. This is an error that needs to be worked on. The Sentihood dataset includes 11 labeled categories for aspects. The labels are directly related to the whole sentence rather than a single aspect. To measure the performance of our model on categorizing aspects, we convert the aspects into their vector form and graph them. We then perform clustering with 11 classes to analyze coherence and see if they reflect the true categories. This is the result. Each point represents a sentence from the dataset, and their color is the true category. We found there is a varying level of coherence between the clusters. For example, the live, transit location, and price categories appear to be closely related in the graph. The categories which have similar properties are dispersed around each other. Quiet and safety, and shopping, dining, and nightlife are similar categories and hence close to each other. Each of the vectors on the graph appear close-knit. This is expected as the topic of discussion is similar. The overall coherence of our clusters reflect the eligibility of our category extraction process. Finally, we can look to incorporate an experiment with machine learning. By training our model with the output of our rules as a feature for discriminative learning, we will be able to fine-tune and adapt it to different datasets. So we have proposed and implemented an approach to aspect extraction utilizing an unsupervised rule-based coreference resolution model. What started out as a simple model has proven itself to be a valid approach, outperforming previous similarly unsupervised approaches. Additionally, the clusters produced on each aspect's word vector are coherent to a satisfactory level, reflecting the eligibility of our baseline model.